Hello everyone. Today we'll learn how to easily understand integration by parts and how to use it to solve problems more easily. Typically, when solving problems using integration by parts, we use formulas on the screen. Does it look a bit complicated? We'll use a simple form of equation and explain how it is derived. We'll start with the product rule of differentiation. When you differentiate a term that is the product of two functions, u and v, we use the product rule. We first differentiate u and leave v as it is, and then we add this term to the product of u and the differentiated v. And if we rearrange the equation with uv prime as the given, we get uv prime equals uv complete prime minus u prime v. Then if we integrate both sides with respect to x, the left side becomes integral uv prime dx, and the right side becomes integral uv complete prime dx minus integral u prime v dx. However, the integral of uv complete prime dx in the middle can be simplified as just uv since it's integrating a term that has been differentiated with respect to x. Okay, so this is the formula for integration by parts that we'll use from now on. Now, all you need to do is identify which part corresponds to u and which part corresponds to v prime in the problem to find the solution. If the problem involves definite integration, meaning that the range of x to be integrated is given, the formula will change accordingly. Let's use yellow to make it more visible. The result of the definite integration must always be a constant. Therefore, we need to substitute b and a into the right-hand side of the formula to find the definite integral of uv, and we also need to calculate the definite integral of the last term from a to b. To summarize, there are indefinite and definite integrals, and the formula for integration by parts consists of these two equations that you see here. Let's take a look at our first example. The first problem is the integral of x times e to the power of negative x. As you can see, it is a product of two terms and it's not easy to solve by any means. However, if you have a product of two terms, you can consider using integration by parts. Now we just need to decide who will be u and who will be v prime. Let's first set x as u and e to the power of negative x as v prime in the order that they appear. Then u prime is 1 and v is the integral of e to the power of negative x, which is negative e to the power of negative x. Typically, we set u as the term that is easy to differentiate and simplifies when differentiated, and set v prime as the term that is easy to integrate. Of course, there are exceptions, and I'll prepare another video explaining those exceptions and providing examples. As shown in the equation above, we can substitute the values we found into the u, v, u prime, and v terms on the right-hand side. The first term we need is u times v, which are x and negative e to the power of negative x, respectively. And we need to take the integral of u prime v, which is 1 and negative e to the power of negative x, respectively. The formula can be further simplified to negative x times e to the power of negative x minus integral e to the power of negative x times negative 1 dx. Do you know the integration method for exponential functions? There's a very fast integration method called the box rule, where the integral e to the power of box times box prime dx is e to the power of box plus c. We just need to find the values to put in for the box and the box prime, and the integration can be quickly completed. If you want more detailed information, you can click on the link in the upper right corner for a more detailed explanation and examples. If you put negative x in the box and negative 1 into the box prime, the integrated result is e to the power of negative x plus c. Therefore, the answer to the above problem is negative x times e to the power of negative x minus e to the power of negative x plus c. As I mentioned earlier, when choosing u and v prime, we should choose a term that is easy to differentiate and simplifies upon differentiation as u, and a term that is easy to integrate as v prime. What if we didn't know this fact and choose u equals e to the power of negative x and v prime as x instead? In that case, u prime would be negative e to the power of negative x, and v would be x squared over 2. We can substitute these values into the integral to see what happens. Our integral becomes e to the power of negative x times x squared over 2 minus integral negative e to the power of negative x times x squared over 2 dx, which is more complex than the original integral because the integrand in the second part has a higher degree than the original x term. In other words, choosing a combination of u and v prime that result in a higher degree term than the original integrand will only make the integration more difficult. Now, let's take a look at the second example, which is the integral of x times cosine x. Again, we have a product of two terms, so we'll use integration by parts. As I mentioned earlier, x differentiates to a simple 1, so let's set u to x and v prime to the easily integrable cosine x. Then u prime and v are found to be 1 and sine x respectively. Now let's substitute these values into the formula. The first term is uv, so it becomes x times sine x, and the second term is the integral of u prime v, which is the integral of 1 times sine x dx. Since the integral of sine x is negative cosine x, this formula becomes x times sine x minus parenthesis negative cosine x plus c, which simplifies to x times sine x plus cosine x plus c. This is our answer. In this example, we have ln x. The problem is the integral of x squared times ln x. Well, once again, let the easy to differentiate x squared be u. Then naturally, ln x becomes a v prime. U prime will be 2x, and now we need to find v. However, since we don't know the integral of ln x, we can't find v. What should we do? Up until now, we've let u be x, but this time, let's try the opposite. We will let u be ln x and v prime be x squared. Then we'll find u prime, which is 1 over x, and v, which is x cubed over 3. Are you worried about the increase in the degree of x in v? However, it's not a problem because at least in the terms we need to calculate in the right hand side, there is no logarithm and u prime is also a function of x, so the integration should be easy. So when we write uv, it becomes ln x times x cubed over 3. And we can see that the integral of the second part is simplified to negative integral of 1 over x times x cubed over 3 dx. Therefore, the equation becomes x cubed times ln x over 3 minus 1/3 times integral x squared dx. And when we calculate the integral of the second term, it becomes 1/3 times x cubed times ln x minus 1/3 times x cubed over 3 plus c. So the answer is 1/3 times x cubed times ln x minus 1 over 9 times x cubed plus c. Do you find it difficult to find u and v prime? Basically, when x is the term, let u be x. And when a logarithmic function like this comes out, make the logarithmic function u. There are exceptions, but we'll cover those in the next video. I will solve 2 more examples. This example will be a little special, and the next example will deal with the definite integrals. This problem is the integral of e to the power of x times sine x. Both functions have easy derivatives and integrals, and especially e to the power of x has the property that it does not change even if it is differentiated or integrated. Sine x also doesn't get any simpler even if you keep differentiating. It just changes from sine x to cosine x. Unlike the previous examples, this problem requires using the integration by parts twice, and the method of finding the answer is a bit different. Let's get started. First, let u equals e to the power of x, and let v prime is sine x. In fact, it doesn't matter if you start the other way around. Once you have u prime equals e to the power of x, and v as a negative cosine x, substitute them into the formula above and write down the terms on the right hand side. uv becomes e to the power of x times negative cosine x, and the integral at the end becomes the integral of e to the power of x times negative cosine x. When you simplify the minus sign, the formula becomes negative e to the power of x times cosine x plus integral e to the power of x times cosine x dx. Something doesn't seem to have been simplified, and it looks like only sine x has been replaced with a cosine x. Now, let's try to solve this integral again with the integration by parts. Let's set u equals e to the power of x, and v prime equals cosine x, as we did before. Then u prime becomes e to the power of x, and v becomes sine x. To make it easier to see, Let's write our problem in yellow. Integral e to the power of x times sine x dx is first written down as negative e to the power of x times cosine x. And then we write down the terms we just found through the integration by parts. The first formula becomes e to the power of x times sine x minus integral e to the power of x times sine x dx plus c1. Here c1 is the arbitrary constant of the integration. Let me rewrite this equation once again. If we factor out the common factor of negative e to the power of x from the first and the second terms of the right hand side, we get negative e to the power of x times parentheses cosine x minus sine x minus integral e to the power of x times sine x dx plus c1. I have also written the right hand side integral in yellow. Can you see now? The yellow integral expression that we are trying to find on the left hand side also exists identical in the right hand side. What should we do now? If we move this yellow integral expression to the left and simplify it, can we find the answer we are looking for? Okay, let's move the yellow integral expression to the left. Then we'll have two identical integral expressions and the remaining terms will be on the right. Now, if we write this as 2 times integral e to the power of x times sine x dx, the right hand side will become minus e to the power of x parentheses cosine x minus sine x plus c1, and dividing both sides by 2 will give us the answer to the integral e to the power of x sine x dx that we are looking for. Here, instead of c1, I use another arbitrary integration constant c. Ultimately, since it is an arbitrary constant, we do not necessarily have to use the value of 2. This problem was one in which we could find the answer through two integration by parts without actually performing the integration. Remember that when integrating functions that maintain the same form, even after differentiation and integration such as e to the power of x or sine x, multiple integration by parts may be necessary as shown here. Let's try solving a definite integral problem using integration by parts. To use integration by parts for a definite integral, we need the formula shown above, which is simply the original integration by parts formula with the values of a and b substituted. Now, let's solve the definite integral of x times sine x. Let's set u as x and v prime as sine x. Then u prime becomes 1 and v becomes negative cosine x. Since it is a definite integral, we need to substitute pi over 2 and 0 for x times negative cosine x, and the remaining part becomes the integral of 1 times negative cosine x dx. If we take out the minus sign inside the integral and simplify, we get minus bracket x times cosine x from 0 to pi over 2 plus integral of cosine x from 0 to pi over 2. Now we substitute pi over 2 for x and subtract the value when it substitutes 0. This gives us minus pi over 2 times cosine pi over 2 minus 0 plus sine x from pi over 2 to 0. Since cosine pi over 2 is 0, the first term becomes 0 and the second term becomes sine pi over 2 minus sine 0, which ultimately gives us the answer of 1. We can use the integration by parts to solve the integrals with the two multiplied terms, and by deciding which term becomes u and which becomes v prime, we can easily find the necessary terms to substitute into the formula. Is today's video helpful? If it was, please subscribe and like the video. I will continue to make better videos for you in the future. This has been your Math Guardian, Alex.